Sometimes when you are conducting fieldwork, you might employ a clustered sampling design, and you would have to create those clustered points before you go out into the field to do your data collection. There are two ways to go about this. The first one is that you don't actually know where your clusters are, so you first have to select the center point of your cluster. The second one is you know where your clusters are, but you still need to know what the points are in the vicinity to the center points of your clusters that you will eventually navigate to in the field. The first method uses the create random points. You're going to create the cluster centers that you will use to then subsequently create additional points for in order for loading into your handled GPS before departing to the field. You're going to have a restraining feature class, and this is this in particular Bora Kalalo National Park. Let's say I'm interested in having a 5-point sample design, so I want 5 clusters. I will specify the number of random points to be created, and I can also specify the minimum distance to be in place between each center of each cluster. So if I were to now, for example, say that I want a minimum distance of 1,000 meters, so a kilometer from one cluster to the next, I could specify that, and you'll see 5 points randomly created within this particular extent. Now, one of these falls into a cliff for a dam. It's one of the limitations of this particular tool. If you want the dam to be excluded from the analysis, you'd have to actually cut it out so it wouldn't form part of the current extent. I can also reduce that restrictive distance between clusters, and you'll see that some of the clusters might actually be much closer to each other. Here are the 5 points that represent my clusters. I now want to create additional points in the vicinity of these points for eventual sampling in the field. I've got 5 clusters, and let's say I want 100 sample points in total. I will then create additional 20 points around each of these sample points or centers of the clusters for subsequent navigation to in the field. I will first define an area of interest around each cluster. Initially I said that each cluster had to be 1,000 meters apart from each other, so I'm going to use the buffer tool to define the area of interest around these cluster centers, and I'm going to give it in this instance a 500 meter neighborhood. Once I run that, I can then create additional points inside of those buffers that I will use for sampling. That means I'm going back to the random points generator, and in this case I'm going to specify those buffers that I've created as the delimiting outline for my sample points. I've got 5 clusters. I want 100 sample points, which means I should have 20 additional sample points per cluster, which I'm now going to create using a random point generator. I run the tool, and you'll find that there are now 20 points that are created within these buffers. At this point, they don't have any locational information attached to them yet. That is another tool called Create Geometry. You input your points. You specify the fields that you want to create, for example, lat and long. The coordinate reference system that you would like to use, WGS84, for example, would be a good geographic coordinate system. And you specify what you're going to create. So latitude falls on the y-axis and longitude on the x-axis. You run the tool, and you'll find that all of these points that you see on your screen will now have additional fields where the latitude and the longitude is captured correctly. This you load into your handheld GPS, and you can navigate directly to this once out in the field to do your sample collection. Now, the second scenario where you have existing clusters would follow the same procedure. You would start out with known points, create the buffer, and then specify how many sample points within the neighborhood of the center point of your cluster you want to use, and then load this into your handheld GPS and navigate to it in the field.